Binomial expansion. Let's understand the concept. Binomial, bi stands for 2. So two term expansion. So you can see bracket is there. Inside bracket there are two terms. By default I am taking a positive sign. So a plus b bracket raised to. I am changing the power of that. Right now I am taking starting with 0. Anything raised to 0 is 1. So I am writing this one term. Now I am increasing the power of same terms. A plus b, now 0 becomes 1. Anything raised to 1 is the same a plus b. A plus b bracket square is a square plus 2ab plus b square. A plus b bracket raised to 3 is a cube plus 3a square b plus 3ab square plus b cube. A plus b bracket raised to 4 is a raised to 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b raised to 4 and so on. So there is a sequence. If the raised to power is say 0, I am getting one term which is 1. Raised to power is 1, I am getting 2 terms. Raised to power 2, I am getting 3 terms. Raised to power is 3, I am getting 4 terms. Raised to power is 4, I am getting 5 terms. So if the raised to power of a plus b bracket raised to n, then I am getting n plus 1 terms in the expansions. Now another trend. Forget about this one. Let's start with a plus b raised to power 1. Raised to power of 1, you can see here first term is your a. So here also first term you are getting a because a is getting a raised to 1. And b term is also there but b raised to 0 because full raised to power is going 1 with a. So b is not getting anything. So times b raised to 0. And anything raised to 0 is 1. So b raised to 0 is equal to 1. Then in the second term, a power is not there, so a power is reduced. Initially it was 1, now it becomes a raised to 0, and initially b raised to 0, now it becomes b raised to 1. So you can see that as the terms progress, as the number of terms progress, first term power decreases by 1 and second term power increases by 1. Same trend you can see in the next expansion. The raised to power is 2. First term is a is getting full power, that is 2, and b will get nothing, that means 0. Then a power is 2 becomes a raised to 1, b power is 1. B power was 0, now it becomes 1. Then a power is 0, b raised to 2. Similarly 3, so just focus on first term, a raised to 3, now a raised to 2, then a raised to 1, then a raised to 0. And same way, b raised to 0, so b raised to 1, b raised to 2, b raised to 3. One more, a plus b raised to 4, a raised to 4, b raised to 0, a raised to 3, b raised to 1, a raised to 2, b raised to 2, a raised to 1, b raised to 3, a raised to 0, b raised to 4, and so on. So this is the way the binomial expansion works. Now focus on their coefficients. The coefficient of a plus b raised to 1, right now it is 1 and 1. Here it is 1, 2 and 1. Here it is 1, 3, 3, 1. Here it is 1, 4, 6, 4, 1. Then here it is 1, 5, 10, 10, 5 and again 1. How does this work? Specifically in a paper 1 where you are not allowed to use a calculator, this works according to the Pascal triangle, and that is why purposely I wrote down everything in a triangular format. So understand this as a Pascal triangle concept. So first I know the coefficient, anything raised to 0 is a 1, so here it is a 1, I am writing here. Then this is 1 and 1, I am writing here and here. You need to remember first two terms, first two steps. Once you know that, this bring 1 over here, this bring 1 over here, 1 plus 1 becomes 2. So 1, 2, 1, which you can see here, 1, 2 and 1. Then again, bring this 1 over here, bring this 1 over here, bring this 1 over here, 1 plus 2, 3, 2 plus 1, 3. So 1, 3, 3, 1, you can see here, 1, 3, 3 and 1. Then a plus b raised to 4. This one comes over here. This one comes over here. 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. And this comes as a 1. So 1, 4, 6, 4, 1. That is 1, 4, 6, 4. And again here it is a 1. Same way I can calculate for a plus b raised to 5. So this 1 is coming over here. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. And then last one here coming over here. Similarly, if I want to calculate for a plus b raised to 6, first I will write down the a power, then I will write down the b power, and then I will write down the coefficient. So first term will get full power, that is a raised to 6. Second term a raised to 5. Third term a raised to 4, a raised to 3, a raised to 2, a raised to 1, and a raised to 0. In the same term, b raised to 0, b raised to 1, b raised to 2, b raised to 3, b raised to 4, b raised to 5, b raised to 6. Now write down the coefficient. This one comes over here, right here. 1 plus 5, 6, right here. 5 plus 10, 15, right here. 10 plus 10, 20, here. 10 plus 5, 15, here. And 5 plus 1, 6, here. And last one is here. So this is what your a plus b bracket raised to 6. What if the middle sign is minus? If the middle sign is minus, this gives a positive sign, this becomes a negative, positive, negative, positive, negative, and again positive. So alternate signs will change. Positive, first is always positive because middle sign is negative. Positive, negative, positive, negative, positive, negative, positive, negative, and so on, depending upon what is the power. Now, what is the binomial expansion? Actually, formula. So I'm using the same format, a plus b bracket raised to n. So this coefficient like 1, 6, 5, 15, 10, 20, and so on, those are considered as a combination. Combination, there is a formula. If you have n objects and you are choosing r objects. So for example, if you have 1, 2, 3, 4, 4 pens you have, and if I'll ask you to choose one of them, and if you don't want to choose anything, so you will say, I don't want to choose anything. That means I'm not choosing anything. That is 4C0. Or you can choose 4C1. Or you can choose 4C2. Or you can choose 4C3. Or you can choose 4C4. So you cannot choose more than what you have. So it won't happen 4C5. That is the wrong thing. And you cannot choose negative pen or negative object. So it cannot be 4C negative 1 or 4C negative 2. So remember one simple thing, when you are doing a combination like NCR like this or this or this, this is the same way. There is no division sign over here. This is only NCR. Out of n you are choosing r. R and n cannot be negative, be fraction, cannot be decimal. Okay. So first thing NC0, then NC1, then NC2. This will continue up to NCN. When it's a NC0, first term, that is A, will get the full power, that is here, and second term B will get this power, that is 0. Or A power and B power add up to the total power, that is n. So n plus 0 is n. Then now NC0 becomes NC1. This is your first term. Write in a bracket. Also B can be negative, so that is why I'm suggesting that write A and B in a separate bracket and write the power outside of the bracket. Now NC0 becomes NC1. A power is decreased, as we have seen that a raised to 6 becomes a raised to 5, a raised to 5 becomes next term a raised to 4, and so on. So a power is consecutively decreasing, a raised to n minus 1, a raised to n minus 2, and last term last term is a raised to 0. When a is having a full power n, that time b is having a 0. And if you will see the last term, a is reduced up to 0, that time b will getting a full power, that time both are same, that is NCN. If this is NCN is not matching, for example, if this 4C4, then a raised to 0 and b raised to has to be 4. If you are getting this 4 and you are not getting this 4 or 3, then you are doing something wrong. So nc0 becomes nc1, nc1 becomes nc2, a raised to power is decreased, a raised to n becomes a raised to n minus 1, a raised to n minus 1 becomes a raised to n minus 2, and last term is a raised to 0. b raised to 0 becomes b raised to 1, b raised to 1 becomes b raised to 2, and last term becomes b raised to n. Please understand, every term has to be written in a bracket. If the middle sign is negative, then it will help you to make a better calculation. Now, in case if you don't want to use a Pascal triangle and you want to show some working about NCR, this can be written as like this, or NCR or NCR. That time your formula is written as n factorial, that means total number of objects factorial, over r factorial times bracket n minus r in bracket factorial. Don't write this bracket out factorial inside the bracket. It is n minus r. First you do subtraction and then you take the factorial. Now what do you mean by factorial? The basic definition of 0 factorial or 1 factorial is 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. So when I say n factorial, it is n times n minus 1 times n minus 2 times dot 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 up to 1. So whenever you do any factorial, you start from that number getting multiplied by a 1 reduced number. So if I'll say 5 factorial, I will start with 5 times 4 times 3 times 2 times 1, and that's it. Don't go below 1. One more format of this concept. If you will see, we always start with nc0. So this is your 2c0, or this is your 1c0. This is your 3c0. This is your 4c0. This is your 5c0. This is your 6c0. So in all cases, your answer is 1. So your whatever is your n, if your r is 0, then the answer is 1. This is the shortcut. Similarly, c1, 2c2, 3c3, 4c4, 5c5, 6c6. That means whatever is your n, if your r is also same, then the still answer is equal to 1. You can use this formula, you will get the same answer. Also, now look at the second. 2c1, this is 2c0, this is 2c1. 2c1 is 2, 3c1 is 3, 4c1 is 4, 5c1 is 5, 6c1 is 6. So whatever is your n, if your r is 1, then the answer is n. So if I'll say 10c1, your answer should be 10. If I'll say 100c1, your answer should be 100. These are the concept behind binomial expansion, which includes Pascal triangle, which includes this formula, which includes the combination formula, as well as the factorial. Thank you.